is divided by x minus 2. Part B is x minus 2 a factor of f. C, divide fx by x minus 2. D, write, and this is important, write the function or the polynomial as the product of three factors. Right, that is what we need to do. I think my pen is running out of ink.
Maybe you just didn't have the cap on.
I gotta get another one. Sorry?
Are we doing this question by ourselves or as a class?
We're going to do it together. Yeah, we'll do it together. Yeah.
This question C, the same as question A. Divide.
Okay, so we're going to go through this question together. And then we're going to have more questions. And finally, if time permits, we can do the factor theorem. Okay, so solution for part A. They say, what is the remainder when f of x is equal to, well, f of x is divided by x minus 2. All right? Okay. So you know that the answer is going to be f at 2, right? On the side. The remainder is equal to just f at positive 2. Okay, and then if you evaluate, then the answer is going to be, you tell me. Yeah. Okay, so we're going to say therefore the remainder is equal to 0. Okay? So the remainder is equal to 0. Okay, this is very, very important, and this will take us to that thing that we call the factor theorem. Okay, so if the remainder is equal to 0, okay, then we can answer the next question B. They say is x minus 2 a factor of f?
Yes.
Yes, because the remainder is equal to 0. So that means that you're going to have a set of brackets. So you're going to have 1 bracket, 2 bracket, or whatever. And then you're not going to have a remainder. So this definitely is going to be a factor of that one. Okay, so we're going to say as r equals 0, comma, x minus 2 is a factor of f. Okay, so we're going to do this more formally when doing the factor theorem, but this is sort of where we're going to. All right, so we had that in here, and then they say divide the polynomial by x minus 2. Okay, so we're going to do the synthetic division. All right, let's do synthetic division because it doesn't say how. So let's do that. Okay, so for the synthetic division, we need to write down the coefficients. So we're going to say 1, minus 2, negative 1, and positive 2. And we need to put the 2 in here. And then we're going to repeat what we did before.
So we could have used any methods for this one, right?
Yeah, for this one, doesn't say any specific method. So we're going to do the easy one. Yes, sir.
Should J be the product of two factors?
We'll see. Okay. Okay, so this is a cubic. So I mean that, we'll see what happens. Okay, and then let's do what we did before. So in here we're going to have 1, and then we're going to multiply. So 2 multiplied by 1 is 2. And then we're going to operate these two numbers, so it's going to be 0. And then we're going to have 2 times 0, which is 0. So in here we're going to have minus 1. And then 2 times negative 1 is minus 2. And the remainder, okay, is consistent with what we found before. Okay, so we done this. And part D is when you have to write this polynomial as the product of 3 factors. All right. So then we're going to say f of x is going to be equal to the divisor, which is x minus 2, multiplied by, and also remember in here, we went from x cubed, so I mean that this is going to be square, so it's going to be 1x squared. Okay, we don't have the x because it's 0. Okay, but we have the constant, which is negative 1. Okay, and then you can see clearly that this can be factor. Remember this? This is difference of 2 squared. Okay, so this is going to be x plus 1 and x minus 1. Okay? And you can see clearly that x minus 2 is one of the factors. All right, that's it. So it looks like it's not too hard, all right? Okay, yes.
For B, is x minus 2 always a factor? Because when we write up the polynomial, the device is always first, so why does it matter if the remainder is 0?
Because you have to add, because there's no remainder.
Yeah, can you see that in here we don't have plus something else?
Yeah.
Yeah, so that is telling you that the remainder is equal to 0. So we don't have any remainder. It's like when you do this. Can you see that when you do, yeah. Can you see that when you do, for example, if you do 10 divided by 3, then the answer is going to be 3 plus 1/3, right? And then you can see that this is the same as if you do the divisor multiplied by the quotient and then add the remainder, right? Okay, and then you can see that 3 is not a factor of 10, clearly. All right, so because you're adding something else. If you have something like that, then yeah, it is a factor. And if you compare this with something like, let's say, 12 divided by 3, see what happened. So it's going to be 4 and 0 remainder. Okay, and then if you do this, like the divisor multiplied by the quotient, and then you're going to have a 0 remainder. And have a look, when the remainder is equal to 0, can you see that the divisor is one of the factors? Yeah, that is what we mean. Okay? Right. Okay, question 4.
You've got someone to go up on the board.
Oh, yeah, okay. Not yet. Okay, find K. Okay, so this is the easy part. Okay, but then there are some questions in which you have to think about it and are not that easy. Okay, but this one is not too bad. Okay, they say that you gotta find k, so that when this polynomial p of x equal to 2x cubed minus x squared minus x plus k is divided by x minus 2, comma, the remainder is 0. Okay, so that means that in this case the remainder is given. Okay, so you know that the remainder is 0. And then you have to find the answer for k. All right? So we're going to say solution. If the remainder is 0, we know that we can write p of 2 equal to 0, right? Is that clear? Okay, so if the remainder is equal to 0, then we can write this. Okay, p of 2, which is the remainder, is equal to 0. Okay, but this means we're going to evaluate 2 in this expression, and that will lead us to find the answer for k. Okay, so then we're going to say, well, this is equivalent if you say 2 and then 2 cubed minus 2 squared minus 2 plus k equal to 0. Okay, so you can see that these two expressions are equivalent. All right? Okay, and then from here, well, you can easily find the answer for k. So this is going to be 16 minus 4 minus 2 plus k. And then you can find the answer. All right? Okay, so this question was, a little bit different. So this is still an application of the remainder theorem, but this time the question was about finding the constant, okay, when the remainder was given, and it was equal to 0. Okay. Another question like that? Okay, so we have question 5. Question 5. Okay, they say find the coefficient of m. Find the coefficient of m if find the coefficient m. Should say find the coefficient m if 3x is polynomial 3x squared minus mx plus 4 is exactly divisible by x plus 1. Okay, when they say that a polynomial is exactly divisible by other one, mean that that other one is a factor of the polynomial. Okay, so exactly divisible means that you don't leave any remainder. Okay, or in other words, the remainder is equal to 0. Okay, let's see how we're going to do. Okay, so we're going to do this in 3 different ways. Okay, we're going to do this in 3 different ways, just to illustrate how the whole thing is connected. Okay, but obviously later you're going to do what is easy for you or depending on the question. Okay, so we're going to say solution. Okay, so we know that P of negative 1 is going to be equal to 0 because P of negative 1 is the remainder, right?
Yes.
Okay, and they say that the remainder, it doesn't say, but it's implicit in the question. They say that is exactly divisible by that. So we're going to say, we know that P of negative 1 have to be 0. Okay? Otherwise, it wouldn't be exactly divisible by that divisor. Okay, and then we're going to do exactly what we did to the other one. So we're going to substitute negative 1 in here, and that will let you find the answer, right? So then we're going to say 3 multiplied by negative 1 squared minus m multiplied by negative 1 plus 4 must be equal to 0. Okay, so these two are the same. And then, Emilia, what is the answer for m? So the negative m is equal to? Negative 7. That's it. Okay, so that is the easy way. Okay, now we're going to actually do the long division. Okay, because sometimes you have to do so in question like that. So make sure that you send question like this, do it in that way. All right. We're going to say by long division, we have, okay, let's do the long division. Now we're going to be doing a little bit of algebra, very simple algebra. Okay, I hope you don't get confused. Okay, so we need to divide this polynomial 3x squared minus mx plus 4. All right, so we got that one. And can you see that in here we have something that we don't know? Okay, that is what we need to find, right? Okay, so let's do exactly what we do when we do the long division. So I need to multiply x by 3x squared, right? Sorry, 3x. 3x. Okay? And if you do so, then you're going to have 3x squared and then plus 3x, right? Okay, now is when you need to be very, very careful because we're going to be taking away. Okay? Okay, so we know that these two cancel each other, but then we're going to have minus mx minus 3x. All right, what is the common factor in there when you have minus x? Or you can take the minus outside, so you can put this as minus m plus 3 and then put the x in there, like that. All right?
Why are they on opposite sides? Does it matter?
It doesn't matter. You can put the x at the front. I'm writing this as something multiplied by x. That's all. I'm writing this as a coefficient of x. Okay, and then we're going to bring the next one down. I'm doing this question like this because sometimes you have to do it this way. All right? Okay, and then we're going to do exactly the same. So if I want to have this, I need to multiply x by minus m plus 3, right? Okay, so if you multiply negative m plus 3 by x, then you're going to have that expression. Okay, is that clear? Okay, let's put it. Okay, and then we're going to multiply negative m plus 3 by 1, so we're going to have minus m plus 3. Okay, and then we're going to do the subtraction. All right? Okay, now, can you see that if you do the subtraction, these two, well, will cancel, right? So we know that. And then we have to do 4 plus this. Okay, so we're going to have 4 plus m plus 3. Okay? And this is the remainder. All right? Okay, so that this is the remainder. And we know that the remainder is equal to 0. Okay, that is given. So therefore, we're going to say, therefore, 4 plus m plus 3 have to be equal to 0 because this is the remainder. So therefore, m again is equal to -7. All right? Okay, so can you see that there is consistent between this and this? Okay, now we'll do the synthetic division. Okay? Yeah, I really want to do this in the 3 different ways in case you have a question like this. Okay, by using synthetic division, we have, okay.